Dear students, I am Khalid Rauf. I have completed my MPhil in physics from the Punjab University, Lahore. Today I am here from the platform of the Professor Academy. So I am your physics lecturer. Today we discuss a very important branch of science which is of physics. Physics is actually a branch of science which deal with the energy, matter, and relationship between them. It means that physics is actually an interaction between energy and matter. That's it. So we understand with an example when an atom bomb can be exploded, it convert into energy. It means that when an atom bomb it is in matter form and when it explode it convert into energy. It is a very simple example to understand of physics. Now here we discuss the different branches of physics. There are many branches of physics like nuclear physics, classical physics, quantum physics, optical physics, and many more. But here we discuss two of most important branches of physics, the classical physics and the quantum physics. So start with the classical physics. The branch of physics deal with the macroscopic particles. Macroscopic particle means that particle which we see from our naked eye, and these particles we see in our daily life. All those particles or all those things which we can touch that are macroscopic particle which totally depend on classical physics. Now we discuss the quantum physics, the branch of physics which deal with the microscopic particle. Microscopic means that particle which cannot be seen from naked eye. Which for the see of the quantum particle we use microscopes, and these particles only see by using electron microscope or any other microscope. So now we discuss a very important laws of physics on which classical physics totally depend. These are the Newton's laws. Newton's laws are presented by Sir Isaac Newton in 1686. These are totally classical physics dependent laws and these are very important laws in physics. So start with the first law of Newton. A body at rest will remain at rest or moving with uniform velocity will continue to do it until a net force act on it. The net force is very important role in this Newton's second law. So it means that a body which is at rest will always remain at rest. So a body is moving will be in moving until a net force act on it. A very simple example is stone on earth, which is the example of a body which is at rest, and the particle of gas which are in cylinder, that is the example of uniform motion. It means that a stone is on the earth at rest and the gas particle are in moving until a net force act on it. So due to net force mean external force, and due to external force their behavior or their motion may be changed. Rest body may move or moving body may take a rest. Now we start a very important law which is based on the classical physics, and most of interviews that law will would be asked. That is Newton's second law. When a force is applied on a body, it produces acceleration in the direction of applied force, and that acceleration is directly proportional to the force of a body applied, and that acceleration is inversely proportional to the mass of a body. It means that when a force acting on a body is very high, the acceleration of a body is also very high, and when the mass of a body is very high, the acceleration of a body is small. So it means that a heavy body having smaller acceleration and lighter body having greater acceleration. So by combining these above results, Here we see that acceleration is equal to kf over m. K is a constant of proportionality. We put value of k is equal to 1. So this is our final relation, which is actual Newton's second law, which means that force is directly proportional to the acceleration of a body. And this is a Newton's second law triangle, which can be easily explained the Newton's second law validity, that when when a high force is applied, the more acceleration is maximum, and when acceleration is mass of body is maximum, then acceleration is minimum. So now we discuss the Newton third law, which is a very important law in physics. Action and reaction are equal in magnitude but opposite in direction. It means that action is acted on one body and the reaction is acted on an other body. So it is a very important law in our daily life. A very simple example in our daily life is when we hit a ball on the wall. The action is acted on a ball by the wall. When we hit a ball on the ball act an action on the wall, and as a reaction, the wall also act a reaction on the ball, and with the same force, ball return back to us. It means that action and reaction are equal in magnitude, but these having always in opposite direction. So thank you so much, dear students. Hope so. You like my lecture, and it's request to you like, share, and subscribe our YouTube channel, the Professors Academy. Thank you very much.